Okay, so we're gonna get started here in a couple of minutes. I'll just give it 5 minutes or 2 minutes or something, just so that people can join our YouTube channel. I know that people are still looking for the link, so we'll just make sure we share that, and then we'll get going in a few moments.
Is my microphone working all right?
Yep, Mike, we can hear you loud and clear. That's great. We are just giving people another minute or two. We'll probably start around 5 minutes past. Okay, I think that's hopefully given everyone enough time to make the YouTube channel. Funnily enough, the YouTube channel, slight bit of delay on the line. So if you do have any questions as we go along tonight, post them in and we'll pass them along to the speakers. So yeah, let's go on with the evening. Thank you everyone for coming. We are London Gophers, and this month is a very special London Gophers. Not only is it Pride, but we're also helping support the Black Lives Matter movement, along with our amazing sponsors, JFrog, who you will hear from in a moment, and Tyke and GoBridge for making this happen. And so thanks very much, as always, to our amazing sponsors. And with that, I'm going to pass over to Ari from Go Center to say a few words about Go Center, JFrog, and what they're doing with Go. So over to you, Ari.
Thanks, Dom and team. I appreciate it. Hi, everybody. I'm Ari Waller, and I'm the Meetup Event Manager with JFrog, and we're the makers of GoCenter.io, and we're really excited to be a sponsor for the London Gophers. For those who don't know, JFrog is a software company. We're based in the Silicon Valley in California, and we're known across the world for our flagship product, Artifactory. We have about 600 employees, 10 offices globally, and more than 3 million developers use our tools on a daily basis. What a lot of people don't know yet is that we have an entire community software team that primarily develops in Go on GoCenter. With the introduction of Go modules in version 1.11 and their standardization in 1.13, we noticed that the Go community lacked reliable sources of truth for trusted Go modules. So in January 2019, we released GoCenter to the community as a free, security-focused central repository for Go modules. So feel free to check us out at GoCenter.io. On the next slide, I want to tell you all about our annual conference that's coming up. We have some really exciting speakers that are going to be there, and we want to offer 10 tickets to London Gophers community today. And really, it's on a first come, first serve basis. You see the URL there, and I'll put it in the chat a little later, as well as a code, and that code is good for 10 uses. And you will be able to come see some pretty exciting speakers. Obviously, we have some really great ones that you may have heard of. Jessica Dean, Azure Avenger from Microsoft. Brendan Burns, co-founder of Kubernetes, and of course, Kosuke Kawaguchi. And I know I messed that up, and I apologize with all due respect to the gentleman, obviously for the Jenkins founder. So again, we have some other ones that are not listed here, and we're very excited. All proceeds are going to be given to charity from this conference. The cost is only $20 if you don't get one of the free ones and you still want to hear these exciting speakers. But also for those who do get a free ticket, don't worry. We at JFrog are going to be donating the $20 on your behalf. So hope you can join us. And that's going to be July 1st. And the full schedule and activities are on our website. But again, thanks for welcoming us into your community. And we're so excited to be part of it. Really appreciate your time.
Thanks, Harry. It's really good to have sponsors like JFrog on board, and especially with what you're doing, donating money towards charities for COVID. That's really good. And I'm sure everyone who uses Go and has used tools like NPM before in the JavaScript world will be very happy that Go Center is a thing. We won't have to go through the same things other communities have gone through. Cool. So what have we got in store tonight? Yeah, we're going to kick off the evening with Michael Mundy talking about portable Gophers. Sounds a really interesting title, and knowing Mike that it's going to be a deep dive into some interesting parts of Go. We're then moving on to a lightning talk from Udit Gera, who's actually our first international speaker at London Gophers. He's dialing in from India, so that's going to be really fantastic to have a first international speaker. And then we're going to round up the evening with Bartek, who's one of my personal heroes. He's taught me so much over the years, and optimizing Go for the cloud. But first of all, I want to take a minute or two to just talk about Black Lives Matter movement. At the minute, this is something that's affecting everyone around the world. And I think it would be really damning if we didn't mention it during our meetup. I want to make sure that everyone in the Go community and everyone who attends London Gophers feels welcome, and that everyone around the world, no matter whether their skin color or their beliefs, can come to a meetup like this. And I also want to just say to everyone that I think it's up to all ourselves to make this better. We need to educate ourselves, we need to be vocal, we need to vote, and we need to be the change that we want to see in the world. And we need to do better as a community, we need to do better as organizers of this community, and we need to make this, make the change. And now more than ever, we are seeing that around the world. So yeah, I just wanted to take a second to talk about that. Moving on, we also are celebrating Pride Month this month. So welcome to all our LGBTQ plus members of the community. We're so happy to have you all here with us, no matter your gender, your background, your sexuality, or anyone of all different preferences. We are honored to have you here. It's unfortunate that Pride probably won't be going ahead this month. Normally it's an amazing parade, but we are lucky to have you as part of our community. I want to make sure again that you all feel welcome. And in saying that, I just want to remind everyone that London Gophers follows the Go Code of Conduct. And this is Cassandra just going through some parts of the Code of Conduct. So it's be friendly and welcoming, be patient, be thoughtful, be respectful, be charitable, and avoid destructive behavior. Now, I believe that everyone in the community will follow these values by default. But yeah, I think it's important to remind ourselves that we do follow this code of conduct. And so what else do we have for this evening? Oh yeah, we're looking for new speakers to pick it up a little bit. Anyone who wants to come and give a talk at London Gophers, please reach out to us. We've got a number of different talk slots. We've got a 10-minute talk, which Udit will be doing later. And that's 10 minutes just on a small nugget of information. We've got our regular longer slots, which are 30 minutes, and we'll see Mike and Bartek do those. And as organizers of the community, we can help you do many things, refine your topic, making sure that your slides look good, and we'll help you all the way through the submission process. And this could even be a launching pad for going on to do other conferences. There's many of us here, both who are organizers like Kat, who's going on to go and speak at Go EU tomorrow. So we can definitely help and mentor people where we can. So reach out to us at, I think it's glug-organizers. We'll pop it in the YouTube chat as well. But please reach out. We'd love to have some new speakers. some talk ideas. Go-to's coming up. That's really interesting. I've seen some tweets recently around the use of generics, the ever controversial subject. We could have talks about context, understanding scopes, and concurrency in Go. So there's loads of great subjects that we can speak about. So please reach out, help us get new speakers, and yeah, let's just keep building our community. And with that, I'm going to hand over to Michael Monday, who will be talking portable Gophers. So Mike, let's hope the demo gods are with us. And we haven't tested your connection yet, but I'm sure it will be great. If you just want to try presenting, and we can hand over to you.
Great. Yeah, so so it's still saying you're presenting.
I can. Do I need to? I'm wrong.
Share.
Yeah, if you at the bottom, you should be able to share. If not, I can try and exit, and we can try and. So I've just exited. So can you in any way now?
I'm just saying that you cannot start screen share while the other participant is sharing.
Okay, I have just ended my stop share. There we go. Sorry about that. That was all on me. Can you do it now?
It's definitely up. Let me just see if I can.
Ah, that's
sorry
about that.
That's fine. Yeah, thanks very much. So hopefully you can see the screen. So yeah, so what I wanted to do today was to do a bit of a talk about portable Gophers in the case. So first of all, I'll talk a little bit about what I mean by portability. So there are some very portable Gophers.
Mike, I think you're sharing the presenter view.
Oh, really?
Don't worry, we can do that in post-production. We can take it out in post-production to steal a line from Matt.
Hang on.
It's all right. We'll get there in the moment. So yeah, as we're going through Mike's talk, feel free to post questions in the YouTube chat, and we can either get Mike to answer them directly in YouTube, or we can paste them across to him over here. So yeah, keep chatting away, ask questions as we go along. We'll make sure we grab them and flag them up to Mike so we can answer at the end. And also make sure you think of some questions for Bartek and Udit as they go along. Have we lost Mike entirely now? Has he dropped off the call? Oh, here we go. We've got Mike back again.
Sorry about that.
All right.
All right, let's try that again.
Yeah.
Yay, Zoom. Why is it still in?
Oh, there we go. Yeah, now you click on gas. Maybe we take it back to the first slide. And like I said, we'll edit it all out later. So if you go back to the first slide, we can make this look professional. So
for the first time ever, yeah. So the talk today, as I said before, is about portable Go. So I really want to talk about how to use Go on different systems. So what we mean by portability when it comes to Go is really taking source code, your program, compiling it for different targets. So for Go, we would normally take our platform independent source code. So it's UTF-8, you can read it on just about anything. You can read it on your phone, you can read it on more or less anything. You put it through a compiler, and then you end up with an executable program you actually run. And that executable program, because Go is a compiled language, is specific to a particular platform. So what portability really is starting with the same source code, trying to, and compiler, and ending up with programs that would run on different systems from the same source. So that's kind of what this talks about, is why you'd want to do this, and sort of gotchas that can come along the way, and also why Go is a really good language for doing this. So this slide is it's a bunch of different systems that you might want to run Go on. So up top left, we have a MapBot Pro. So this is an Intel system running OS X. We've got here a Microsoft Surface Pro running Windows on, again, an Intel chip. Got a Dell server that could be running Linux. It could be running OpenBSD, lots of different things. So I guess most people are probably used to those kind of systems and programming for them. But there are a whole bunch of other things out there as well. I mean, from the common stuff, like things like iPhones. So these run iOS, and the processor is an ARM64 processor. And to kind of giant systems like the Summit supercomputer in the US, which is a IBM Power system, and it runs with NVIDIA accelerators. Got this RISC-V development board. So RISC-V, if you're interested in computer architecture, really interesting architecture, especially if you're kind of just want to dip your toes into computer architecture. It's a really interesting chip design, tries to be as simple as possible in the core instruction set, and it's designed for teaching as well as being a commercial and open source hardware platform. So that's one target. That actually support for RISC-V and Go is relatively new. That was only added in Go 1.14, I think. So that's kind of exciting stuff. Then in the top right corner, something else that I find interesting, which is this is Amazon's Graviton 2 processor. So this is Amazon's ARM64 processor that they've designed from scratch. And I think it's just for AWS, don't quote me on that. But it's interesting that the cloud providers are going all the way from just like buying servers to then designing the servers themselves, and then going all the way into designing their own processors. So it's kind of interesting to me that they would go that far. And again, you could compile Go programs for that using the Go compiler and some of the techniques that I'm about to show. Then finally, in the bottom right-hand corner, we have a system that's particularly close to my heart, because my day job is actually writing code for this system. So this is the IBM Z or Z mainframe systems. They can trace their lineage all the way back to System 360. There's actually still some instructions in there from those days in the 60s, but they're designed really for high availability and sort of critical infrastructure kind of applications. So Go runs there as well. Hopefully runs well. If not, ping me. I got a bug report today, so that's not great. But yeah, so there's lots of different places and environments you might want to run Go in. And I think a lot of these are really exciting, like being able to run on open source hardware. So Power and RISC-V are open source instruction sets. So stuff like that, it's kind of cool and interesting to me anyway. So from Go compiler's perspective, a platform is really made out of two things. An operating system, so most of you will be familiar with an operating system. So this is things like Windows, Linux, OS X, Mac OS, which are both, I think, called Darwin in Go, BSDs, Android, ZOS is also one for Z systems. And also underneath, because Go is a compiled language and it runs directly on the processor, it needs to know which processor it's targeting. So These are a bunch of different processes. We looked at some of them on the previous slide. And not all the operating systems and processor architecture combinations are valid. Like you couldn't have Android running on the mainframe, but a lot of them are valid. And actually all of these architectures will run Linux, which I find kind of cool. So one thing that Go does really well is cross-compilation. So you have your operating system and processor architecture that you want to target. In this case, this in command, I've chosen Linux and a MIPS system. So that will go into more detail as to why that is on the next slide. But essentially, you can, just by setting some environment variables, compile your program for a completely different platform. And we'll see what that looks like in a second. But it's really powerful because most other compiled languages, this is really hard to do and it's really frustrating and annoying. So it's one of the things I really like about Go, and it makes it really easy to just test that your code compiles on different platforms and things like that. And also for low memory targets, things like ARM development boards, MIPS development boards, Go is really good. Cross-compilation is very important for those kind of targets because they don't really have that much memory or processing power. Compilation is quite an intensive process, really. So it's best just to compile your application and then move it onto the system rather than trying to compile it in place. So now, this is almost certainly not going to work. I was going to try a demo. So let's see if we can get this to work. So hopefully you can see my screen still. So on the left, I have my just Windows system for Linux, Linux system for Windows, something like that. Command prompt. And on the right, I'm actually hopefully still logged in. I'm running on a router which has been flashed with OpenWRT. So this is a distribution of Linux specifically designed for wireless routers. And if we look at the processor we're running, you can see we're running a MIPS processor. Has some Bogger MIPS. It runs some different instructions and things. It's only single core, so it's not super powerful. And what we can do is we can just compile our program, Hello World in this case, or Hello particular architecture, and then copy it across. Don't look at my password. Oh, I'm not allowed. There we go. Okay, so this is on the local networks. Hopefully it'll be quite quick. Okay, so we can see we've got Hello World 2. I also have a previous one that I just for emergencies. So now we can run our Hello 2 binary, and you can see it prints out hello from Linux/MIPS. So that's literally how easy it is to cross-compile for different platforms. And this particular router, it doesn't fit on the screen, but it really doesn't have very much memory. It's only got like 128 megabytes of memory. So you couldn't really run the compiler on that, or certainly not for a big project. So it's kind of cool that you can just run it on a different machine. Right, so that's cross-compilation. So we're done, right? We can all have a party and go home, and we can just run Go programs on all our various devices using that system. But of course, in reality, it's not that straightforward. There are lots of things that might go wrong, that interactions with the different systems that might cause your program not to work or not even to compile for a particular target. So one example of this is CGO. So C code is not very portable, really. There's lots of historical reasons for that. But I mean, C code, the C language itself is quite portable, but the way it's typically used is very often not portable. So for example, you could be using CGO to interact with a graphics library like OpenGL. And then all of a sudden your Go program requires OpenGL on the system, and it requires certain interfaces with that system, and it might require even a graphics card to be in that system. So as soon as you start using CGO, you open a Pandora's box of unlimited things that could go wrong with your cross-compilation and portable programming. The other thing with CGO is it's quite hard to cross-compile for. You can do it, and in fact, that's how most of the Linux non-AMD 64 binary compilers are built and released upstream, by the Go project themselves. They actually cross-compile a lot of that stuff on AMD 64 machines. But there's a whole bunch of stuff to do with setting up GCC and multi-arch and all these kind of things. So if you can get away without using CGO, do. If you can provide an option not to use CGO, maybe you're using CGO for performance reasons, that's great too. So what can go wrong with the operating system? So I won't focus too heavily on this. I think a lot of people are familiar with the difference between operating systems. And I'm not super familiar, so I'm going to take the easy option and not talk about it too much. But for the most part, what you run into with operating systems is that different operating systems use different APIs and you can do different things on them and interact with the system in different ways. And there are several Go packages that are platform specific for doing this sort of stuff. Things like the syscall package, which is deprecated and you shouldn't use it anyway, but people do. And also the xsys packages for Unix and Windows. Again, you can do raw system calls for both those platforms and do all sorts of things that are very platform specific. So if you want to write a portable program, and you use those libraries, you're going to have to find a way to use build tags or some other system for conditionally compiling them and testing on different systems and that kind of stuff. So ideally, try to stick to the standard library. It does, for the most part, provide really good platform-independent APIs. And if you do need to reach for system calls for something specific, try and, like I say, guard it behind build tags. So if it's just a performance thing, or if it's not critical to the application's behavior, just guard it with some build tags, and that way, at least it will work on different platforms, maybe not quite as fast or whatever. But let's go into the guts of process architecture, because this is what I actually enjoy. So what is a process architecture at first? Because you may have heard me talking about instruction sets and ARM64 and all these kind of things. But really what it is a big book, which has a bunch of information about how a system works and how you can encode programs so that they run on that system. So it might, for example, say how an instruction is encoded in binary, how the instruction behaves in certain situations, might talk about constraints on instructions. So for example, one thing I'll show a bit later is if a load isn't naturally aligned, so that is a 4-byte load isn't aligned to a 4-byte address, then you might see a fault, that kind of stuff. So that's specified in the ISA. But for the most part, you don't really need to care about the instructions. Unless you're writing assembly, the Go compiler will take care of all of that for you and don't need to worry about it. What you might need to worry about is things like the memory model and the endianness of the platform. So when I talk about memory model, what I'm really talking about is how different cores interact with the same memory and what and how they share memory between them and how that's observable from the program. We'll talk about that again a bit later on. And then there's also endianness, which I'll talk about now. So endianness is really just how a processor designer has decided to lay out multi-byte values in memory. So CPUs are byte addressable usually. Well, they certainly all are these days. So you have in memory a set of bytes, and say for example a uint32, that's 4 bytes. Well, there are 2 ways you can lay that out. You can start from the least significant byte, which is little endian, or you can start from the most significant byte, which is big endian. So big endian is more human readable. You can kind of see how it, if you look at the bytes, they're kind of laid out in the same order as the number. So it's great for assembly programming things. Little endian is kind of nice in that it has the property that the first byte is always the least significant byte. So it's always this right-hand bit, which is quite nice for some applications. But how can we see that in Go programs? Well, this is a test I wrote. We could try running it on the MIPS machine. But essentially, what it's doing is it's doing an unsafe pointer access, and it's pretending that a pointer to a uint32 is a pointer to a uint16 and loading that value. And what happens is on a big endian machine, you will get 1, 2, 3, 4, because that's on the left-hand side of the array. Whereas on a little endian system, you get the value 5, 6, 7, 8. So this test would fail on a big endian system. And I'll pause here for a second, because one thing that's going to come up in these examples a lot is the use of the package unsafe. And there's a reason for that. Go actually does a really good job of removing endianness and other similar platform platform implementation details from the programmer. Like, it was specifically written so that it's actually quite ugly and hard to write this kind of code. But nevertheless, people do try. So this is the sort of thing that would happen, for example, if you're using unsafe pointers to pass around opaque types, and you're using different structs to decode them using unsafe pointer conversions. You can easily use the wrong size, and if you're using small size on little endian machines, it'll work, and on big endian machines it won't. And you also, so this is how you would fix it, sorry. So you would just, rather than, in this case, using that unsafe pointer, you could just do a cast and it would work on both systems. Again, this is another example of an endianness issue. So here we have a byte array, and again, you're just trying to read it using an unsafe pointer, and on a big endian system, it won't be 1, 2, 3, 4, 5, 6, 7, 8, because it's in little endian byte order. And so again, you can just reach for a platform independent API, such as the binary encoding package, and that's great. You can load it, and actually, but underneath the hood, it does all sorts of optimizations and will produce pretty optimal code for that load. So another thing I mentioned was unaligned memory accesses. So this is typically, you don't see this so much anymore, but particularly sort of ARM 32-bit type CPUs, embedded CPUs, they quite often don't handle unaligned accesses very well. So this is where you're trying to load for example, a uint16 from an address which is not a multiple of 2 bytes. So I've kind of artificially created one here by taking the address of X, our uint32 up here, and adding 1 to it. So this will be naturally aligned to 4 bytes. So by adding 1 to it, I'm making it naturally aligned to 1 byte, essentially. And so on a system, you might, like an ARM system, you might see this. Either it would give you a bus error or something like that. Or even worse, it would work, but the kernel would trap the underlined access, insert a bunch of code to do it for you, and then return you control. So it would completely destroy performance, which if you're using this stuff for performance is not ideal. And quite often with that kind of stuff, you can use bit shifts and masking and stuff to get around that kind of problem. So this one, it's a bit complicated, but really what I'm talking about here is memory ordering on CPUs, so on different cores specifically. So what a instruction set or architecture manual will tell you is the sort of guarantees that a processor gives you as to the order in which memory operations happen. So what this really boils down to is on, say, if you have a 2-core system and core 1, writes values A, B, C, then on core 2, you might see the values written out as A, B, C. So that would be a strong memory ordering system. You wouldn't be able to see C happen before B. But on a weakly ordered system, like ARM systems, for example, you don't get any of those guarantees with normal stores. So a core that's writes to ABC might appear on the other core to be written as CAB, for example. And this causes problems if you're using just normal non-atomic type variables to interact between different threads, basically. So different Go routines are spinning on variables that aren't accessed atomically and with no specific memory order. Now, this will work reliably on Intel machines because the stores are always done in order on each core. They'll always happen the same order and they'll appear that way on different cores. But if you run this on something like an ARM machine, then it could easily fail. Now, luckily, there is a flag you can use in Go test -race, which will tell you most of the time you're hitting this. But in general, you just shouldn't write code like this and use a channel or something instead. Using atomics directly is quite a bad idea in Go because interactions with the runtime, the way Go routines are scheduled, kind of needs to understand some stuff about when Go routines are blocking and stuff like that. So unless you just use them for simple stuff like doing a counter, using atomic adds, I would try and avoid trying to write code like that if I could. Another thing, just quickly to point out, so some platforms use what we call fused floating point operations. And this happens because when you do a floating point operation, so this is like an add 2 numbers together, the resultant number might not fit in the original size. And so what happens is that number is rounded. And when you use a fused floating point operation, the rounding happens less often. And usually this is found with fused multiply adds and fused multiply subtracts. So this kind of floating point calculation. So you might do one number times another number, subtract another number. And on a fused system, it will do all of this and only round at the end. And this is good because it's faster and it's also a bit more accurate in general. But it does mean you get a slightly different result. And these can compound as well. So if you're designing tests that rely on the output of floating point calculations, it's a good idea to make them relative. And this is good in good practice in general with floating point stuff because the operations aren't associative. So if you do 2 plus 3 and 3 plus 2 are not the same in floating point, well, they are if you use those actual numbers, but in general, x plus y and y plus x are not the same in floating point. So is that true? Well, you need 3 variables, sorry. You need x plus y plus z is not the same as y plus x plus z in floating point. It's not associative. You can't do that kind of operation reliably without causing rounding in different ways because of this rounding operation between each operation. So there are a bunch of other things you can do. So if you're writing assembly, obviously that's not very platform independent. Hopefully you realize that if you're writing assembly. I find it's really good to have a generic implementation to go with any assembly for multiple reasons. Even if it's just to kind of keep you honest about your assembly and whether it's really necessary. For example, a while ago, we took out the RC4 assembly from Go, and part of the reason for that was it just didn't really provide any performance benefit over the pure Go code. The compiler had advanced, and it was just not worth it anymore. And having that Go code available for both testing and also to be able to remove assembly later when the compiler gets better is really useful. There's some issues around performance. So some targets, especially embedded kind of type targets, A, the Go compiler isn't necessarily as well optimized for them. B, there may not be as much hand-coded assembly in the standard library for those kind of platforms. So you might run into performance problems with applications, could lead to timeouts, that kind of stuff. Memory requirements, we saw that a bit about the when we're talking about the MIPS cross compilation. Like, you don't really want to be running the Go compiler on a tiny platform, and the same is true of other programs that use a lot of memory. And this last one is kind of interesting. It's you can run into some weird issues around sometimes 64-bit numbers won't be aligned to 64-bit addresses on 32-bit systems, and this can mess with atomic accesses. So in general, try and avoid atomic accesses if you can. If you can't, there is lots of stuff you need to do basically to get that to work reliably. There's some proposals, I think, about changing that, but the alignment issues really stem from alignment issues in C, and trying to be compatible with it, I think. And there are also a bunch of other things that maybe you might run into, but much more obscure than those. I think those are most of them, the main ones. So if this has piqued your interest at all and you haven't been put off by all the things that can go wrong, there are some ways that you can integrate testing on multiple platforms into your projects. Travis CI you can just add all the architectures you want to run on. You can use something like QEMU. It's a bit fiddly, but it will allow you to run Linux on an emulated processor architecture. So you can try out your program on like an ARM64 emulated machine, for example. So that's great if you don't have access to the hardware. And particularly if your tests are quite quick to run, that isn't that much overhead to run them in QEMU and test on different architectures. Docker has this buildx, which is, I think, the experimental part of the CLI, which bundles up QEMU a little bit for you. And I know I haven't used it myself, but I know Dan Narty was using it because he pinged me about it and seeing a bug. So yeah, but that's a potentially quite nice way, especially if you're using containers to package your binaries of targeting more than one platform. You can use something like Docker buildx to do all that for you, and you just pick which platforms you want to target. So a few takeaways. I think really just try and keep things simple. Clean Go code that uses a standard library, doesn't use syscall and stuff, doesn't use unsafe, is actually really often very portable. And certainly in my experience, almost everything runs out of the box on any platform that I use. I think probably the most common things I run into are the fused multiply adds and tests. And also on 32-bit platforms, sometimes constants can not fit in integers and things like that. So, but usually just using normal Go code, it will run fine. And that's very powerful as well, because things like you could run something like rclone maybe on some of these, on my wireless router if I wanted to. That kind of stuff is kind of cool. think about portability when optimizing code. So usually it's when optimizing code that you end up introducing portability issues, or adding features that are platform specific is the other place. But so it's worth thinking about portability, using build tags where necessary in order to maintain that portability, and having fallback code if you can, that's generic and works across platform, but maybe isn't the fastest. And then finally, yeah, if you can, try running on multiple platforms, even if you only try 2. That's like a big, a big step a lot of the time, and can really help with if you ever want to add more. Like the first one is usually the hardest to get working. So yeah, so oh, and well, I remember, so there's a rumor that MacBooks are going to be moving over to ARM64 chips. So apparently that might be announced next week. So this might become more relevant. If you're using MacBooks as your daily driver, you might have to worry a lot more about portability than you thought you used to. So with that, thanks very much for listening. I'm on the Gopher Slack and other places if you have any questions. And yeah, thanks for listening. Thanks to the organizers, obviously, for having me, and do a great job every month.
Thanks very much, Mike. That was an amazing talk. It makes me realize how little cross compilation I do. As far as I go is normally if I'm running on Mac or Windows compiling for Linux. So you really opened my eyes to the world of what can be done with cross compilation. We've got 1 or 2 questions from YouTube if you're happy to take them. Let me just find, where did I put them? So first one, we've got is there a way to check for non-portable things in Go?
I haven't really used any tools or anything specific. The unsafe package is a good indicator. Look for .s files, that would be assembly files. Make sure that they're properly build tagged. You can also look for the syscall package, sys/unix package. That crops up a lot if you're trying to do operating system portability. So yeah, there's a few like those kind of things. And even if you just try compiling your program for 386, that would give you some knowledge of whether your application works at 32-bit, for example. So that's another way to just a quick check you can run on your normal development environment.
There's more sanity checks rather than a golden ticket somewhere. And then the other one from one of our YouTube viewers, Romanic Breen, was, when doing cross OS or cross architecture code, why use Go over C++ or Rust or something else which is much lower level?
Well, obviously it's better. Otherwise you wouldn't be here. But on a more serious note, I mean, I don't have a huge amount of experience with Rust. In general, I would say probably if you're looking at Rust, you might not write the same goals for your project as if you're already looking at Go. But in general, for something like C++, it's very easy to write code in C++, which is not portable. So for example, you can use reinterpret casts all over the place. It is fully backwards compatible with C, so you might end up with void star pointers that hide details about the types that are hidden within them. And that can lead to all these kind of problems. All of the problems with the unsafe package I saw are just day-to-day C++. You see them all the time.
Yeah, I can definitely feel that pain. I'm stuck in C++ hell at the moment. I'm doing lots of progress to try and get around that. Well, fantastic. Thanks very much, Mike. And I think this talk really shows how the broad spectrum of Go, going from the kind of really micro kind of cross compilation stuff all the way through to what Bartek's going to talk about later, and the macro cloud level. So let me just find out where my slides have disappeared to, and they are here. Thank you very much, Mike. Let's switch over to here. So thank you everyone for joining again tonight. Here's all different ways you can get hold of either us, the organizers, or the community. We've got our Twitter handle, London Gophers. Please follow us, retweet us, make sure we can grow the community. Obviously, well, hopefully most of you have seen meetup.com/London Gophers. This is growing every month, and where we put out the call for a meetup each month. We also have Slack, where our membership is growing as well, along with the normal general channels and specific channels around tooling and building. There's also a #London channel where quite a few of us hang out and chat. And then also, if you're watching live, you know fully well about this bottom one, but youtube.com/London Gophers, and which is where we put both all our live streams, and we'll split up the videos after the talks and put it on there. So please follow and share all of these so we can help grow the community. And with the community in mind, we have a London study group. This is run by Beth, who I don't think is with us tonight, but Beth runs a study group, which is amazing. They go through the Go programming language book, and this is just a fantastic way if you're around. I think they might be doing them virtually now as well, but study through the book and learn more about Go. Oh, yes. One of our sponsors, JetBrains, is giving away a free IDE for 3 lucky people each month. All you need to do is go to this URL, so gophers.london/raffle, put in the code remote. That'll send a tweet out, and we'll pick 3 lucky winners each month. And just to note, this is not just Golang. Golang's a great IDE. You can also get the IntelliJ Ultimate. You can get the Rider for C# and games programming. So yeah, it's really worth entering that raffle to get yourself a free IDE, or just do what the rest of us do and use Vim. But either way, it's a great IDE. Enter yourself into the raffle for a chance to win that. Even more competition time. We heard from Ari earlier from Go Center. Ari's got a number of t-shirts to give away, so I'll just leave it on this slide for a moment, so that if you want to take a screenshot, there's a chance to win a number of Go Center t-shirts. As you can see, massive fan of Go t-shirts, so make sure you get yourself one of those. Again, just either scan the QR code or follow the link at the bottom. And with that, we will have Udit speaking about transactions in PostgreSDB and Go. And again, I'm really excited about Udit joining us. He's one of our first international speakers, and especially during lockdown, doing virtual meetups, I think this is super important to be able to share the London Gophers community wider around the world. So Udit, welcome to the community. Thank you very much for volunteering tonight, and I'm going to stop sharing so I can hand over to you.
Thank you.
So you should be able to share your screen now, Udit.
Yeah. Yeah, so
Fantastic.
my talk is about transactions on Postgres and Golang. So a quick introduction about me. My name is Udit, and I'm working in a organization called Tokopedia. So Tokopedia is an Indonesian e-commerce. So I'm working there as a backend software engineer, primarily coding in Golang and sometimes in Python. And these are my Twitter handle and email, so we can connect on that also if you have some questions later on also. So let's start with the basic. So what are transactions? So a transactions is basically simply a unit of work that we are going to perform on a database. And so simply transaction is executed as a single unit of work, so they can, and inside that single unit of work, it can have multiple operations. Like inside a single unit, it can have multiple update, delete, or read. And a transaction may or may not change the content of a database. So there is a myth around transaction, that transactions are always used for update. They are used for update, they're preferred for update, but it is not compulsory that we are going to use transaction only for update. We can have 10 read queries also in a single transaction. And the most important thing that the transactions follow these 4 properties, which are known as the acronym is asset properties, and which is atomicity, consistency, isolation, and durability. And these are the most important properties, and that is why the transactions are most preferred or used, because they help us to keep the accurate, to maintain our data and the completeness and the integrity between the data, so that there is not any differences or atomic differences between two dependent databases. So let us see more about these the properties, that's why for which the transactions are most popular for. So the first property is atomicity. So atomicity means, as I told, that a transaction is a single unit. Like inside a single unit, you can have any number of SQL queries, whatever you want, how many read, write you can have. So the result of the transaction is either failure or success. There is no in between. If, for example, if you have 10 queries inside a transaction and if one of them fails, then the result would be failure and all 10 would be rolled back. And it would be success only in the case if all 10 of them are successful. So the result of transaction is always a single unit, like either a success or fail. And the second property is consistency. So consistency means that in the transaction, once the transaction is completed, then the database should show the updated result or whatever the queries we had in our transaction. So it means that the transactions should be able to successfully change the result in the database. And the third property is isolation. So isolation is the one of the most important properties of transaction, because it helps us to maintain operate, because we can have concurrent transaction also. Like you can run 2, 3, 4 transactions at the same time, and all 2 or 3 transactions can do read, write, update, delete operations on the same tables. So this isolation help us to maintain that compatibility, so that our database, so we don't get wrong result or we don't get logs on database. We will learn more about it on isolation in the coming slide. And the last property is durability. So durability is, once the transaction is completed, then the results should be properly or successfully or correctly updated in the database. Like for example, if we are expecting in our transaction that there should be 10 rows inserted, then after the transaction is completed in the database, if we check from the select query, then there should be 10 rows. So there should not be any mismatch between the transaction result and the actual update. So this is the main diagram of the flow diagram of transaction. So for example, if the transaction is initiated and it has n queries, so if all the query, as I told you, like the transactions follow atomicity. So if all of the queries are successful, then the transaction is committed and the result is succeeded. And if any of the queries from these n failed, then all of them would be rolled back and the transaction result would be failed. So that is how the transaction works as a single unit. You either get a positive or you get a failure. So I have a simple implementation using this database SQL package from of Golang, and all the code is in the Git repo. In this link, I have placed the link also of the Git repo. So let me show you a quick go through the code also. So in this, for example, in this the main file. So this is a simple directory like the Postgres directory. You can see all the code in the Git repo also. So I have a simple Postgres connection, a Postgres database in my local, and so I am using two tables.
Sorry to interrupt you. I don't think we can see what you're sharing. We can still see your slide.
Okay.
I think maybe you need to share your desktop for us to be able to see that code.
Okay.
Don't worry, this happens to the best of us. Mike had technical difficulties as well.
Now can you see?
Yeah, that's much better. Thank you very much, you did.
Now you can see all the code also, right?
Yeah, correct. Thank you.
Okay, yeah. So for example, let us take a simple example. Suppose we have a table. We are having an organization. We have a table called WS employee. So it will store all the result, if any employee join, we will give its employee ID and the employee name and age and gender, just 4 columns in this employee. And we have another table named as WS employee department. So in this, because every employee would be working in a specific team or a division. So in this, we will store the employee ID in the and the department name with the employee is working, and the position of the employee, and the manager, who's the manager of the employee. Like, so in this, there is a constraint in this table, the foreign key constraint, and this means that in this the employee ID or depends upon this employee ID entries in WS employee, because we can't have any employee working in our working in any organization in any division without having its employee ID. So this is just a simple constraint like the foreign key ID. So let us just see a simple example. So I'm using this database SQL package of Golang. So as my all the tables are in my local, so I just connected to the database using this package, and in this let us see how we are executing the transaction. So first of all, I am using a three, as I've told you, like the first we will enter an entry for a new employee. We will insert an entry in this WS employee table, and then we will give the employee any team. So if we start any transaction, so our first query would be inserting an employee info with its basic employee ID and all, and then we will insert a department info. Like first the entry would be WS employee, and then would be WS employee department. So in this transaction, for example, if I say, so in this transaction, we begin the transaction using the Postgres driver. And then first we execute this query. This is the query. This is the query that I want to execute. And I executed this query. If there is not any error in this query, then I will go continue with the logic. Otherwise, the the transaction would be rolled back. So that the rollback is the most important thing, because if any query fails, then we have to roll back, as the transaction is an atomic. So for example, if we are not, so for example, let us insert a simple new entry. For example, if we want to insert an employee info for a new so let us say that I want to, just a minute, so I can show you before inserting also. So for example, this is my local Postgres database, and in this I have two tables like WS employee and WS department, and in this WS employee I have information of so I have in WS employee, I have employees information. I have 6 employees, for example, right now in my company. And if we see in the department, in which department are they? So if we see, I have information of 6 employees also. So I have 6 employees, and all 6 of them are in any department. So if I want to insert any new employee, so that its ID would be, so I will have total count would be 7. So let us take this example, like if we are inserting a new employee, like if we say, if I'm inserting Ben, like, and Ben, this is a simple information according to our database schema. So if I run this binary, simple, the execution. So if I go there and I do this. So it just started like the transaction executed, and then it successfully executed. And why? Because in the main, I'm just calling this function in which my this insert employee details with the struct of the details, and it is just executing all the queries. And right now, none of the query failed. That is why all the 3 queries are successfully committed. Like in the last, we are seeing that they're committing the change. So yeah. So yeah. So in this, if I come here back, if we don't get any error from this, like the commit is successful, then we just log like the transaction successfully executed, which just came here. So now, for example, as I told you, like in this table, in the employee department, there is a foreign key on this. So if I change it, for example, right now, if we check, we inserted just a single row for the Ben. So now our count should be 7. it is 7, right? In both the tables, in both employee and employee department. So we have inserted a new entry for Ben. So let us take an example. Like for example, if this is the last employee ID, which I would get, like for example, if I want to make this query field, like the total 3 queries are in this transaction. Like, so the first one I wanted to be successfully executed, like a new information should be executed in WS in one table. And then while inserting in the second table, like in this query, I want the failure. So I just want to check, for example, so first query after successfully being executed, the number of rows would increase from 7 to 8. And in the second table, I wanted a failure. So in this, the number of rows would be still be 7, would remain 7. But as we are in the transaction, so that all the, then there should be a rollback logic. And then after we would get a failure error and the number of rows would be 7 in both the cases. Because in this, after a successful insertion of this, we will have 8. But because this query failed in this transaction, the third one, then this would also be rolled back. So let me just manually change this. That if I change this to this last employee ID -1, okay. So -1 doesn't exist here. This, for example, if I come here, like in this, like in this, I don't have any -1 employee ID because employee ID isn't negative. Like, but I am manually changing it to -1 for the second table, which is the foreign key table. So it should fail. So I've done this. Let me just come to this and let me just run it. Just run it, and now we were expecting an error, and it came an error like the foreign key constraint failed. Insert or update on this table violating the foreign key constraint, because I manually changed it to -1, whereas -1 was not in this table. So in this, let us see the number of rows. Like in both the table, it should be 7. So in this, after we see like both the rows, the number of rows are still 7 in this, because I manually changed it. This was successful. The rows to change to 8, but the third query failed. So because of that, its insert was also rolled back, and then the result was same. Like the number of rows were still 7. So nothing was inserted. So this is the main advantage of transaction. Like because because in this, if we have n number of queries, like in this, the last query failed, but still all the updates and processing of the upper queries were also rolled back. So this is the major advantage of transaction. That's why we prefer, because they help us to maintain consistency in our database. Otherwise, we will be having 8 rows in first database and 7 in second database, which would be inconsistent data. So handling concurrent transaction. So how to handle this concurrent transaction? For example, if you are executing 2 or 3 transactions at a single time, then we have to do an isolation level. But in this talk, as this is also a very detailed topic, so in the we are not taking up this topic in this talk. I have included these 2 blog links here. So if you can read more about them, the isolation transactions from this. But by default in the Golang, the transaction example we see, we are using this isolation level, like the repeatable read. So what isolation level means, for example, if you have any 4 transactions running parallelly or concurrently at a time to a database, only one transaction would be having a lock on it. So only one transaction would be able to update or delete on one table at a time. And whenever it frees the lock, then only the second transaction gets its right to update or delete whatever it's want to process. So this is how we tackle the concurrent transaction problem. And so now the most important question comes, like when to use transaction and when to not use. So the pros we see, like so the main pro is that when we want to maintain consistency our database, like for example, if we have 8 queries and we and we want all 8 of them to be successfully executed, then only we should assume that our function operation is completed. So if we want to maintain consistency, then transactions are useful. But and what are the cons of using transactions? So the main con is that, as we see in this, the isolation part. So in the concurrent transaction, at a time only, I told you, like, the one transaction would be having a lock on a database, so the other transactions would be waiting for their turn, right? So this increases the time, and this can lead to a slowness. This increases the slowness of the system. So it is basically a simply trade-off mechanism. So like, if we want to use transaction to maintain consistency, we just have to make sure that we include only the least number of queries, but the most important ones in the transactions, for which we want the data to be synced, like in all the tables, and all the other we should not include in transactions, because they will just locking up the table and will increase the time. So in the transaction, the simplest logic is, whenever you want to use a transaction, you just include as minimum number of queries, or as more important queries as possible in the transactions. So I think this was the basic of transactions. Like, what are they? Why are they used? They, as we have seen in an example, they are mainly used to maintain the consistency in all the databases. And for isolation, I've included these links also, so you can go through that also. And now, if you have some questions, so please include them in the link in the YouTube chat. So I will take them from there also.
Fantastic. Thank you very much for that, Uday. It's very informative. I'm going to let you take questions in the YouTube chat, if that's okay.
Yeah.
Fantastic. Yeah. So just hop over to there. And if anyone has any questions, please post them in the chat for Udit to get back to you. That was a great look at transactions in Go.
So I will include the repository link also in this, the YouTube comment. I will post it so that anyone can look at through the code or the blog links that I shared.
That's fantastic. And we can share that out for you later as well.
Yeah, sure.
So let me go back to our slides. So that was Udit talking about transactions. Next up, we have a Go break conundrum. I'm going to talk you through this one, and then we're going to head off for a 5-10 minute break, and I'll leave this up for you. And the conundrum this month is submitted by Matt Ryer, and he's actually submitted 2 questions. These are less conundrums, more on kind of spotting and learning from some mistakes that quite regularly happen. So thanks very much for Matt for sending these in. If any other people would like to send in a break conundrum, we're always looking for new ones, new takes on the conundrum. So Matt's questions are 2, and there's a link to the playground. And these are, how, on the first one on the left-hand side, you see that there's a meseeks object. How would you change this code to make it work as expected? So first off, we need to think about why this code might be wrong and what it'll output. And then what would we change to make it run as expected? The second question from Matt, again, there's a Go playground link for it. The code currently prints an empty array. What do you have to do to make it print, again, the expected array 1 through to 10 with a single change? So thank you very much for Matt for submitting those. And I'm going to leave them up during the break. So now is time for a break, and we will kick off again in probably about 5 minutes. So it's time for everyone to go and grab a quick drink, think about the conundrum, maybe put the answers to the conundrum in the YouTube channel, and we'll have a quick read through them and explain why or how we can solve each of these after the break. So I'm going to leave it there, and I'll be back in 5 minutes. Thank you very much, everyone. All right, I think that's about 5 minutes. So hopefully we've got some ideas in our YouTube. I'm just going to go across my screen and see if I can. Yeah, Derek points out that I had trouble finding the sound. I definitely did for a while there. I lost my Zoom controls. Let me go back to the Bill to Spence, Paul's favorite joke. Does anybody want to paste into the YouTube why this one might not be working, or what you can do to change around to make it work as expected? I'll give you 1 second if anyone is. Maybe just my delay as well. Okay, so we have Derek saying on line 11, we need to change it to be a pointer. So adding the asterisk star. Pass by reference we have from Adam. Nick is saying that set request needs to be a pointer receiver. Again, Tom the same, needs to be a pointer receiver. Okay, so I think you've all got this one. You're indeed correct. The set request needs to be changed to be a pointer receiver. Now, what actually happens here at the moment, it's a value receiver, at least as far as I understand. I'm no expert. The minute it's a value receiver, so it's copying over. And I've taken this explanation from the tour of Golang. What we need to do is, rather than copy the whole value and then set the value on the copied value, we actually want to make a pointer to the original object that we want to put the hello there on. So yes, you were all correct. It's the fact that we need to change the value receiver into a pointer receiver, and this should work as expected. So the next one, I'm going to move on to the next one. It seems as though you all managed to get that one. How about this? What's Matt done wrong here? And both of these are errors that we probably see day to day. So these, I think, are really good ones to go through for these kind of break conundrums. Do you have any ideas what we did wrong here? And again, I'll give it a minute or two just so that people can post some comments into our YouTube thread. Derek saying line 7, that the capacity is 10, the length is 0. Okay. So Derek with another good one. We've got Tim saying that we should turn it into string of length, past length and length for the second and third argument. We've got Adam saying that we should change it to make an array of strings where we're just passing the length. So again, I think all of you are pointing out the same thing. Nick is saying change line 8 as he's iterating over zeros. And we've got the daily ML Python lessons helping us learn Go by saying pass in the length. So yes, you are all correct here. It is indeed that we need to, at the minute, the make is saying we're going to make an array of strings, which is fine. The second item in the parameters is the length, and the third one is the capacity. So you're all right. The length is the second one, the capacity is the third. And so at the minute we're making an array of strings of 0 length, although it has a capacity to hold 10 things. So yeah, there we go. So thank you very much for Matt Ryer for sending those in. And hopefully next month, maybe we'll have another guest conundrum. Who knows? If you want to send us a conundrum, it's the same email. It's glug-organizers at Google Groups, I believe. We'll put it in the YouTube channel. And with that, a quick reminder about the raffle. If you've not done that, grab a screenshot. Same with our Go Center sponsors. Take a quick screenshot and get yourself into the raffle to win some free swag. And with that, I'll pass over to my good friend Bartek. I'm really looking forward to this presentation. Bartek has taught me a lot over the years. We worked together for a number of years, and I really enjoyed both working with Bartek on open source and closed source stuff. He is a font of knowledge, And so, yeah, get ready for a good old school day with Bartek here. It's going to be a good one. So Bartek, if you are there, you are. I will stop sharing and you can take over.
Perfect. Thank you, Dom. Let me try to share my screen properly. I hope this is a proper window. Yes, maybe. Can you see my screen?
Yep, that all looks good.
And perfect.
We can now see your notes as well.
Really? No, that's not supposed to happen. Anyway, that's fine. We can
get it out in post-production, don't you worry.
Anyway, okay. So hello everyone, and I'm super excited to be presenting today in our local London Gophers meetup. I was very often, joining the meetup as a guest, and I'm kind of triple honored that now that I can share what I know about Go and performance from the practical side, right? And I'm speaking from the virtual state, and I wish we could kind of meet in reality, but let's focus on benefits of this situation. For example, I'm pretty sure we have guests from around the world. Actually, we have speakers as well. So it's pretty amazing, and we should look on the bright side, I think. So let's start. We'll be talking today about writing performant Go code and optimizations overall. This talk will be especially valid for kind of Go application running for the infrastructure use cases for the cloud. So something from my area of expertise for sure, right? But to be honest, you can take this knowledge and apply it to any Go program, CLI tools, GUI, or even space, because I don't know if you noticed, but you can dock to International Space Station using Go autopilot. How amazing is that, right? Still, infrastructure mostly runs on cloud, not yet in space. So let's get back to the Earth. We can divide our talk into 3 steps. First of all, we'll touch on the potential misconceptions. So essentially, all the excuses why performance for single information might be not needed. And I want to kind of prove that there might be strong use cases for it, and kind of show where to avoid, but where actually it's worth it. Then we'll discuss how to efficiently approach performance, right? How to start with optimizing. And last but not the least, I will try to fit few optimization tricks that I always check in the code reviews, and I would love for all the community to use them. So we don't need to kind of create automation leaders or review carefully for those. Awesome. So before that, short introduction. My name is Bartek Lotka. I am engineer working at Red Hat in the monitoring team. I love open source and solving problems, and especially those involving distributed systems and Go. I am part of the Prometheus team, and I'm co-author of the Thanos project, which is a durable system for scaling Prometheus. I also love open source projects, open source a lot. So you can see I'm kind of maintaining lots of stuff. And also most of the things are written in Go. So that's because that's my favorite language for those sort of things. I'm also kind of active in the CNCF space. There's a newly created observability special interest group. Please join us. On top of that, I also run some of the software we develop actively on production on high scale, which is actually pretty amazing feedback loop. And I can really recommend that model, kind of mixing of software development and bit of DevOps, as it really triggers very solid development decisions and priority on what matters in your project, right? Especially in open source. Awesome. Let's start with kind of boring part, definition, but we need to kind of understand the basics, right? A code optimization is essentially a method of changing your program, of changing your code in a way to improve something. Maybe, smaller binary size, maybe to make program faster or use less memory, or maybe to improve readability. And there's kind of soft requirement in this optimization process. It is that program must have the same output and side effects as in its non-optimized version. So it should be kind of the same from outside, but from inside, it should be improved. This requirement is kind of soft, as you will see. It might be ignored because maybe you can change slightly the output for the benefit of the optimization, which is kind of useful to know. And yeah, I forgot to click that. Nice. So let's start. And let's imagine we're adding some feature or improvement in the code. You put the proposal, you put the code change PR on the GitHub, and have your colleague or anyone it's reviewing your code, right? And you wanted to optimize things. You did something, and you got something like that. Well, please don't optimize that because we are kind of guessing here, and this is micro optimization. And this might be a good advice, right? There is quite a battle in software development about micro optimizations that might be premature. This means that potentially we would be adding unnecessary complexity and cluttering our code that, for no reason. It might be that optimization is done not on the critical path, so the optimization really does not give much, or maybe optimization is just not needed overall, so we might want to spend time on something else instead. So overall, in many cases, the Yagni rule kicks in, and Yagni means you're not going to need it, right? Meaning that we simply might be wasting our time by adding extra complexity. So from Yagni code practice, does performance matters? I would say still yes. While premature optimizations are evil, generally, there are some basic Go patterns you can stick to in order to avoid basic performance pitfalls. And I hopefully can list some of those tricks near the end of this presentation. Awesome. Let's move to another excuse why someone would or maybe solid reason why someone could ignore optimization. So you propose the code again, and the response you got, well, we care about reliability. This is like obfuscating the code. Don't optimize the code, right? And there is, again, lots of truth here. Let's consider following snippet, right? This is code from Thanos project, literally production code. And Thanos, as I mentioned before, it's kind of extension of the Prometheus, so metric system, metric database. It is horizontally scalable, so it cares about overall performance, right? And this code is responsible for fetching certain data from a file that is memory mapped in Linux. So as you can imagine, very critical path for the project. And we can definitely agree, and you can definitely agree with me as well, that this sophisticated piece of code is not that clear at the first glance, right? Especially if you look closer. There's my favorite function here called YOLO string. It's actually pretty neat. It allows to convert through different types, convert maybe type to string, or convert the same kind of types into each other without extra allocation. So it does not copy anything. It literally maps the memory space to a different kind of variable with different type, which is very hacky, you would say, but actually saves a lot of allocations, right? So would you accept this in your production code? And let's make it interactive. Please comment in YouTube. Would you accept this in your production code, please? I'm waiting 10 seconds. Would you be happy? No, shy people, please tell me. No, Dominic is saying no. No. Okay, we have it in production. Amazing. I need your feedback. Too clever. Wow. Anyway, we have it. We might want to change it after this talk. This is super good. Anyway, please keep commenting. That's super nice feedback. And yeah, at the end, it's fair point. Like, it's not readable that much. However, to avoid extreme optimization, and yeah, we need to kind of avoid extreme optimization to keep the code kind of readable and clean. And after all, we chose Go because of the simplicity, consistency, and readability. That's why it's so efficient to write programming Go, and etc. It has all the benefits. So does performance matters if we care for readability? Again, I will be advocating, yes, performance still matters. We should never sacrifice like too much readability, but there are ways to have performant and still readable Go code, at least from my standpoint. especially if we consider certain performance patterns to be consistently used. Maybe even the COLO string, right? If it's consistently used and everyone knows about the consequences, it's well documented, it can be assumed as not surprising, which means not that very bad, right, in terms of readability. But looks like YouTube chat is thinking differently, and that's a good feedback as well. But however, there are kind of, I think there is a way to create a performant code without losing much of the readability. Also, another excuse we hear, a lot when, well, a lot. You are kind of lucky if you hear that. So you are pushing the code and someone is saying, come on, we have like such big machines. Why you even care about optimizing anything? And for example, AWS has this like, huge bare metal servers with like literally, 200 cores, and they're available, and maybe your company is happy to pay for those. And that gives the impression, yeah, YouTube, I mean, it's not bad. Looks like on the YouTube chat, I'm seeing someone is complaining about smaller sizes. Still, for those big machines, someone could say that you don't need to optimize because, there is this impression that performance will not give much if you can just, do whatever. And actually, this is so fast because we have so many resources. The truth is not that beautiful. In practice, concurrent programming is hard, despite Go having pretty amazing, framework for it. With lots of Go routines and channels, you will hit kind of process scalability limits, and at some point, and think about, cases of resource starvation and garbage collection latency on huge heap. Those problems. So kind of if you have like huge shared memory and it's used across thousands of Go routines, at some point you will have lots sort of limitations. Don't patch the code by another server. I'm so distracted by those comments. I should not read them. But yeah, no, I'm kidding. It's actually super amazing. So yeah, and actually there are other limitations as well. Like maybe we have lots of cores, lots of memory. However, there is something like, memory IO bandwidth. Like maybe the space is huge, but it's not fast enough. And also there are other aspects like disk IO and network and also lots of things. So at the end, you have to optimize a little bit your code, even for those cases, and sometimes essentially to scale out of the single process as well. And this comes to last kind of excuse, which is kind of the misconceptions I see a lot. And I'm so distracted by comments, but no, keep going. I will try to read them offline. So amazing, so good feedback. So with this last misconception, we often hear that, we don't need these optimizations. Our code is like have unlimited horizontal scalability. So why we care, right? And this is actually, I see a lot in the infrastructure culture. And nowadays, if you want to be hired as a backend developer, backend engineer, on top of typical programming and Linux questions and interview, you have to show your skill in designing scalable systems, right? So you have to either design system like Twitter on the whiteboard, or Messenger, or like WhatsApp, or Google Docs, anything. You need to go through different phases of this huge system design and explain how it will scale from 100 users to 10,000 users to million users, right? And at the end, the key concept that every cloud engineer has to know is scalability of the system. It's extremely exciting topic, and essentially means how you should grow or shrink your backend or service capabilities with the traffic, with the request traffic, with amount of customers accessing your server. So when your application becomes too slow or require more CPU or memory than you have available, what do you do usually? How you scale usually? So basic way of doing this is through something called scale up method, which means also like the other naming is vertical scalability. You increase capabilities of your program by just giving more resources, right? You just move to bigger machine, put more CPU, put more RAM, better network, and usually It's single process, single machine. Things are simple. You just give more resources, more money. Now, essentially, this is becoming very boring recently. And for the last 5 years, the new fashion emerged, which is called like scale-out method and kind of horizontal scalability. This means that you can grow your application by replicating horizontally on different machines. And particularly in this model, someone can say that optimizing single process is not really a priority, right? Because you can just another service or virtual machine or container in the Kubernetes, for example. The problem is that, as you've seen, horizontal scalability kind of became a buzzword, and it's a very deep problem, maybe, or a nice thing, depending how you see it. It's a fashion, right? And this problem misconception is actually the true motivation what I'm doing this talk, because in scale-out fashion, it's more exciting maybe, but many engineers are not seeing the complexities it brings, right? And it might be even premature to dive into distributing your application, your program, and using tools like Kubernetes and Kubernetes and Mesos, for example. And just instead maybe focus on quickly optimizing your couple of critical paths in your program and get rid of unnecessary allocations, and maybe allow single Go process to serve thousands of users without issue on the single machine, right? You don't need this complexity maybe. So I want to reiterate, performance still matters. Horizontal scaling, yes, it's nice. It's super, fashionable nowadays, and like actually solving real problems, but it can be extremely expensive and difficult to implement properly. Not mentioning overhead and delay in scaling this way, especially if you don't optimize your Go code. Well, okay, enough of those excuses. I hope I kind of motivated you to look into optimization. So at the end, performance might matter, but it has some consequences, right? And overall, it's hard to achieve like the kind of better performance. It takes time and might impact readability. So how to approach and avoid those problems, right? First and foremost, step number 1, detect the bottleneck and find the problem you want to solve. There's a good rule related to premature optimization as touched before. Don't do kind of any performance changes until necessary, essentially, right? So first rule, don't do it. Second, don't do it. And only then maybe consider some optimization, because it's hard, because essentially you can make lots of mistakes in the beginning and waste your time. So the idea is to find the bottleneck first that you can clearly improve on. But how to do that? Like how to find what's the problem? What's my first problem to solve in terms of performance? So let's imagine, your API, your RPC, your command, your action in the code. Execution is, first of all, maybe slow and just timeouts, so it never finishes. And second option is just crashing, like either the whole machine is crashing, and or maybe this execution is never, or the process itself is being killed, for example, by kernel or operating system. So there is a difference between those two symptoms, let's call it, right? Both symptoms are actually because of the same reason. Host that process is running on does not have enough resources to perform this operation. The difference between those two is actually the characteristic of the underlying resources that is the underlying resource that is saturated. And saturated means that there is not enough of it. So first of all, we have compressible resource. And this means that the resource can be throttled temporarily without stopping the program. You can just give less of those things, right, for a short period of time. This usually means freezing execution of the program, slowing it down, for example, and not giving those CPU cycles, CPU time, and then give something else that is needed, and then get back to the previous process and get the CPU time for for the whole process, right? So those compressible resources, yeah, we can compress them. We can just slow down things at the end, and what we in kind of with those resources, we are seeing the following symptoms of program being slow or just timeouts being super slow, right? So those things like CPU time, disk I/O, memory I/O, network I/O, all of those are compressible. Second type of problem, which is causing those crashes and maybe kind of different behavior, are incompressible resources. And those you cannot throttle. You cannot throttle without causing a failure of your process. And for example, if process requires more memory and there is none available, Linux kernel will kill this process, offending processes, as nothing can be really done. It terminates that process, and which is popularly known as out of memory if there is not enough memory, or just kind of out of memory exception, kind of called. And but there are other incompressible resources than just memory. Essentially any storage, right? Disk, maybe some database even, or power is also kind of incompressible in some way. Okay, so there is a quite important differentiation of here. Like from what symptoms you have, you kind of can already drill down to what kind of resources you are missing, right, in your for your program, and where to look for the optimizations. Okay, we know kind of what resource is being problematic. Now, how to get from the resource to actually the code line that is causing the resource consumption. So maybe extra CPU extra CPU cycles used, or maybe memory allocated. And the quick clue, we'll be using observability signals, but from very high level, right? So first, let's focus on finding the problem of the root cause and the code line for the types of for the problems that are the symptoms are that the process is very slow and timeouts. And usually kind of the backend engineer journey like this starts with an alert because you are on call, you are on the production system, let's say, and you got some notification that something is super slow. Your user cannot access the page, something is happening, right? And this is kind of based on what we have. And for example, this is using Alert Manager, which is based on kind of metrics, Prometheus metrics. And then usually you can navigate to some dashboard, some graph that shows you certain characteristic. In this case, we see a latency or duration of the request, and you can see that immediately it spikes. So something wrong is happening. We need to go and look what's going on. And this is thanks to Grafana and Prometheus, right? And now when we roughly know the component which is slow, we can usually using tracing and, for example, Jaeger. All of those tools are open source. And it allows us to detect some slow request and dive into it and check what exactly phase of this process are timing out and takes a lot of time. Now, thanks of that, we kind of know what let's say process is causing this. So at this point, we might want to get some profiles, right? And to essentially check what's going on and dive super low level into the code. Now, I'm not going to in details explain how you get profile and how to use them. It's very complex, and there probably have to be 4 more talks about this. Yeah, you are free to make one talk on Go meetups as we are looking for speakers. However, there are good blog posts about this, and kind of my slide has some kind of links you can click. Anyway, let's imagine we get the profile. It's kind of fairly easy in Go because by default, Go allows a special endpoint. And you see a flame graph, which consists of kind of CPU cycles flame graph, showing you where the CPU is spent. And another view of it, which is kind of a graph of spent cycles as well, shows the biggest kind of blocks as the biggest kind of as the things that are using the most cycles. So as you can see, in our case, it was a text marshaller. It's kind of a protobuf struct that was causing, maybe slowdown. And this is how we get from the symptom straight into the code line, literally, because this points to exact code line and you can get even the exact code in what package is causing the problem, or the program is spending time on, right? This is lots of work and lots of kind of tools around, but this is how we do it. Now, for the crashing, let's go quickly for this symptom. Crashing is more difficult. Essentially, our symptom might be different. It's just, our process is not running. It cannot run because it's constantly being killed. For example, here you can see kind of Kubernetes UI, or like via OpenShift, but essentially it's a Kubernetes, and you can see that the pod, or like the process, the Go process that is running, which is kind of a autonomous component, is crash looping. It cannot start, and it's kind of bad. So let's try to navigate what code line is actually responsible. So then usually, as previously, we go to the Grafana, we check memory graph, memory metrics, and now if we would follow kind of previous example, I mean, now we can see that the memory is spiking, and immediately after the start, it's getting killed. Now, this is not helpful because, like, I still don't know what exactly code line causes this, right? So let's try tracing, right? Why not? Well, we cannot, because that's not latency issue, and it's not about single request being problematic. It's actually the whole state of the program. Maybe multiple algorithms happening in the same time that is causing this situation of crash, and in this case, memory problem, right? And memory saturation. Okay, so let's try profiling. Nope. Because the process already crashed. So it's hard to get into proper moment of things, of where the things went wrong, right? So you might try it, but it's pretty hard. So as you can see, it's not easy, and I'm not spending I don't want to spend too much time on it, but essentially some way of doing is continuous profiling. So there is a tool called Conprof that we use as well, and it allows you to, it essentially talks to the process and asks for the profile every 15 seconds. So whenever something wrong happens, you can retroactively check the profile and navigate to the code line that actually causes these allocations, which is amazing, especially in those kind of problems with incompressible resource like memory. All right. So overall, as you can see, even detecting and drilling is kind of hard, and we didn't even get into optimizations yet. So how optimizations works then? So we found the problem, we found the kind of code line causing the problem. Now what's next? Generally, both of the kind of all optimizations, both micro optimizations and big system level optimizations, really jumps from one resource to another depending on the bottleneck. For example, you want to have your program to be faster, knowing the saturation of the CPU time is happening. For example, your process is searching for documents in the storage, and you lean and instead of just checking the documents one by one and spending these cycles, and it can take time. You can lean more on disk and memory and pre-compute some index and caches, and this way search operation will need much less CPU cycles and be much faster. However, using more memory, right? Another example, if your program crashes because of not enough memory, you might want to optimize your program to use more CPU instead by implementing some kind of streaming and increase your programs concurrently. And increase the concurrency itself, so you can put more algorithms. It will use more CPU instead of memory. Last but not the least, maybe you want to limit some functionality or change it to improve readability, or I don't know, disk usage, for example. Okay, so it's very important that rarely you can optimize code without sacrificing something else. And this is called trade-off, right? And the key is to choose based on your priority, choose wisely. Okay, so finally, we got into optimizing, and we found the root cause, we have found the exact bottleneck, and exact line of code that is causing this. And we actually agreed on some direction of our optimization. So we want to use less CPU, but more memory, let's say. Now we can start actually coding. Well, not really, because first, to kind of make sure that we perform optimizations efficiently and effectively, we need to learn how to measure the results of your work first. High-level flow would look something like this. First, you have to have initial benchmarks, something that we'll take as a baseline for future comparisons, right? And there are two good ways of doing it. First one are micro benchmarks, usually done by Go test. It's really built in a Go test framework. And there are good blog posts about it. I'm not spending time on it, but it's very not trivial as well. So please read carefully. The second option, how to have the baseline or like measure your improvement, is load test. And this is essentially deploying and checking your code on production and let's see how it goes. Like check the metrics and just try it. Well, not production, like ideally on production, but maybe you want to check it first on some staging and testing. So what happens here is very iterative model. Your benchmark first to have a baseline to compare with. Then you maybe, if you are happy with well, initially you do this benchmark, you do load test. And then if you are happy, I mean, this is initial thing. We know we are not happy. And hopefully load test shows the same results. You are optimizing thing, right? And then thanks to this initial baseline kind of, you can measure again after optimizations. You can measure, you might do micro benchmarks or load test. And in any step, if you are not satisfied, you can do it again and again. And only after you are super happy, you can release it. This is very, very important, right? Essentially, don't trust your instinct. It's never, even for super experienced people, it's a risk. Always make sure you measure the result. This is maybe very tedious sometimes, but every programming language, especially Go, holds thousands of compiler optimizations. And operating system kernels are having even more optimizations, right? That they apply to the process runtime. And they are changing every time. So every time you change kernel, every time you change Go version, it behaves totally different. So there are so many surprises. And the only way to uncover them is actually by benchmarking and measuring often. And this step-by-step with checks methodology is called data-driven decision methodology, let's say. All right, that was the theory. And now I'm out of time, Dom. However, I have 3 optimization tricks and then I finish. So do we have more 7 minutes, let's say, or 10? And it will be interactive a little bit. So depending what's
I think we can, yeah, I think we can go on and we can see what people say in the chat with your optimizations, and then we can take any questions in a different forum afterwards, maybe.
Perfect. Awesome. So let's try like kind of, I have 3 quick optimizations I want to share. So finally some Go. Okay, first one is related to the standard net HTTP package. Sometimes when you read a response from HTTP, you call like this using http.get, and then you check some error, then you scan using bash scanner, and scan the response, which is included in the response.body. And this is wrong. And this is kind of really wrong. And by wrong, I mean it can literally leak lots of memory, and not only memory. So please, YouTube channel, or like chat, sorry. Do you know what's wrong with this code? I give you like 20 seconds. Like, what's wrong with this code? Why it can allocate unnecessary memory on CPU? If you know, please comment. I hope you know, but it's not very difficult. It's not very tricky. Yes, we have first perfect response. There are 2 problems. First is defer rest close, and but there's another one. Closing the scanner. Yeah, you don't need to close the scanner, but you need to close the response. And this is perfectly mentioned by the daily ML Python lessons. However, closing the body is not enough. You need to do something else. I give you like 10 more seconds. Yes, we have Nick, who exactly is on the point. Perfect. So that was quick. So essentially, the problematic bits are here. First problem is that we never close the response body, which means you don't release the HTTP connection. That's how it goes. And so it cannot be reused for incoming requests. This means that instead of reusing connections, this HTTP library will just keep creating new connections, and it will be an overhead in terms of kind of latency and also in kind of resource usage, right? So that's the first problem. You need to close the response body always. Now, second problem is that if either during scan or during error kind of check, we just return without fully reading body, this is a major problem, because body, this is an IO reader, so it allows you to read bytes. Now, you think that kind of, or like I was thinking as well in the beginning, that body is fully read by the HTTP library and just giving you the chunks. That's not always the case. Sometimes yes, but if the body is huge or if it's streaming, you are reading by doing response.body.read, you're reading actually bytes from the network. So if you don't do that, all the kind of layers up to the network are buffered. So you, again, you are leaking memory essentially. So this is very, very important. And this is pretty common problem. And how you solve it, just add those two things, which is kind of very ugly, right? But you need to do it. You need to do it to make sure you drain the body, which is essentially you read all the bytes from the body and make sure you are closed. Now, if it's ugly, and I can agree it's kind of is, you can use kind of the helper that we created on Thanos. You can just copy code as well. It's open source, and it's called runutil, and it just masks everything under this very lengthy function, sorry. And it also makes sure that all the errors are handled, and they're handled by logging them, but you can also, there's another method for handling them by just returning error if the response body is not, you cannot fully read response body or you cannot close something. So this is something I recommend. Awesome. Next optimization. A task. We need to create a new slice and a new map from the data we have in some slice. And usually the slice is big. So I want to copy into slice and map in the same time, like do fan out, whatever. And I want to copy. I don't want to reuse the same memory. So we definitely need to allocate some memory. But can you tell what's the problem here, right? Because what I can say is that this is wrong approach. There is something wrong here. So please, YouTube. Do you know, YouTube chat, our community, do you know what could be wrong here? Why this method it will not leak memory. However, it will be slower than it could be. And it can leak a memory a little bit, which maybe not technically leak, but it can use more memory than it's needed and more CPU time than needed. Okay, I'm waiting a couple of more seconds. Please answer here. Is it as what is not explicitly created on? Initialize with the known size. Perfect, Adam. Yes. Make with len, pre-allocate. All of you are super correct. Yes, this is the place of the problem. We append one by one. So we go for the big slice, we append one by one. So what is happening is that Go tries to, with the append, it tries to grow the underlying array. And kind of the same happens with the map as well below. But with append, it tries to grow the underlying array. And it tries to grow it in a way that is not too big, because you will end up with too over allocation. But it's also don't want to do it so often. However, imagine we have 1 million elements, right? And like every step, how it works is that it will allocate by adding a new item. It will create a slice, an allocate for one item, let's say. Then it will, if you append, it need to grow it. So it will create, it has to allocate a new memory space for 2 elements. that's kind of naive way of doing it, let's say. Obviously, it's more optimized, but generally it works like this. And it allocates a new space, then copy the old stuff to the new stuff. Now you have slice with 2 elements and length with 2. If you want to add more, it doubles the size. So it makes, the Go runtime makes it 4 elements. Right now, the 4 elements memory space has to be again copied from the old stuff that you had into 4 element slice or array, sorry. And then you adding more elements, and then with 5th element, it has to grow again. So it goes and creates an 8 kind of elements array in another memory space. Then you need to copy the old from new, and again, it will double 8, 16, and so on and so on. And for million elements, you can see that it's very tedious. Like, why you do this, right? And Go runtime has to do it because it doesn't have any prediction mechanism for, well, it has a lot of prediction mechanism, but in certain cases, you know better than the Go runtime, right? And obviously it's more optimized than this in kind of certain way. It doesn't maybe always double the size, but maybe do something smart. But generally, this is the idea. So it will over-allocate. It actually don't want to over-allocate. And the problem, kind of why this is problematic, is that with copying, again, we use lots of CPU cycles, but also we kind of don't release memory fast enough to release the old allocations as well. So this is kind of very problematic. Obviously, it's more optimized, but how you solve it? As you probably said, you definitely said before, you have to pre-alloc. So you want to specify the length of the array, if you know about that, in make statement, right? So be nice to Go runtime and tell ahead how many elements you want to push. So it will do that with one operation, not with, a lot more. So this is some advice I would love for you to remember. Now, last part, okay, so I kind of pointed the comments, so there is no point in guessing. The problem here is that we kind of go through the, let's go back, let's go through the, let's say maybe some channel, receive, and we append messages, and with given number of messages in the slice, we want to send them. So we want to split the sending and marshalling process into maximum amount of messages it does, which means that we want to stream a bit. And the problem here is in this layer is that every time we split the messages and we want to add more, we want to reuse this kind of message slice because we just marshal and send, so we don't use that memory. So we want to create, we want to use the same kind of slice. However, we want to empty it. We want to reset it. So usually we can see code that does it like this by just allocating a new string. Now, this is problematic, right? Because again, garbage collection is kind of slower than you think, and slower than you allocate this memory. So even though the previous slice is actually not used, it could be released, it will not be released fast enough. This will, again, kind of trigger additional memory usage. Awesome. Anyway, solution, how to reset properly the slice. This feels hacky, but it's actually proper way of doing it, kind of idiomatic. So you want to reset it like this, which means that you reset the length to 0, maintaining the underlying array size and underlying memory space. So this is exactly what we want. We want to reuse this memory for further messages, right? Awesome. Quick summary. Please, yeah, there are many excuses to ignore optimizing Go, but resist, obviously, with healthy balance. Next, our 3-step process, how to optimize and get to the root of the problem. Please don't overwork, right? Focus on critical paths and focus on your biggest bottlenecks. We don't need to save all the tiny CPU cycles and allocation in our programs. We can do it smartly. Second step, choose your trade-off wisely, right? You want faster execution? Well, probably you want to need more memory for that. Next, step number 4, optimize and measure. Base your code decision on the real data, right? Either micro benchmarks on end-to-end load tests are must-have. and free to kind of try the optimization inside it. Make sure you measure after that. But usually they are helpful, and they are not actually that unreadable, especially with kind of helpers. You can find more in our Thanos Go style guide. We kind of created a special style guide, which is maybe more stricter than normal one. So yeah, feel free to go and look on that. Anyway, just to sum up, all this talk and is about doing this complex thing of optimizing, and essentially we do all of these things to see at the end of your day things like this, right? When you finally do this optimization and it actually solves so many bugs of people having problems with OOMs, with slow latency. It's very painful problems. And finally, when you do those optimizations properly, it kind of benefits. And you make community happy, like the amount of love we got just because we improved Thanos, and we improved lots in terms of kind of memory allocations. It was enormous. People were super happy. And like you see kind of the differences. It was using 100 gigabytes and now 4. So yeah, all of it is kind of worth it, right? So the massive drops. Anyway, it's super nice to see. So yeah, the outcome is that it might be worth it after all, but let's do it smartly. Anyway, thank you. That's all from me. Yeah, I'm taking comments. This QR code has actually this slide deck, but actually I can try to I will put that on the YouTube channel as well. So thank you, and yeah, I will take questions offline, I think.
Brilliant. Thank you very much, Bartek. That was an amazing talk as always. Always learn so much listening to you speak. Like Bartek said, I think we're going to take questions offline. We're running over a bit, but either the YouTube channel, or I think everyone's going to hang out in the London Slack channel as well. So thank you to all our speakers tonight. It's been a great evening. Our next meetup is on July the 15th. And as is becoming standard now, let's assume that's going to be online, unless the world gets back to some kind of healthy model, which I don't think it will. So yeah, assume July 15th online. We'll have a whole host of new amazing speakers. And then August may or may not have a meetup. We need to figure out what's going on with GophCon UK. But yeah, keep an eye out for those. And again, always looking for new speakers. Quick one to give a shout out about. Go Away Fest is coming up 11th, 12th of July. It's going to be an online event. We've got a number of tickets to give away. So if you can get your ticket for $70 using a promo code, which is on this link. So follow that link. There's a chance to win something in a raffle, I believe. And there's also a discount code to get a cheaper entry into the event. So follow that link. Some great online learning. Some big speakers there like Dave Cheney, Matt Ryer. I believe Kat even may be speaking again. So yeah, check it out. Some great speakers. As I said, post-event social, unfortunately, we normally go and walk to have a drink or two at a pub. However, head over to Hash London in the Gophers Slack. I believe that Ben is going to set up a Google Meet where everyone can join if you want to have a face-to-face chat as well. And with that, finally, I just want to say a massive thank you to our sponsors, Ari from Go Center, who spoke earlier, Tyke and GoBridge, who gave us the Zoom access to be able to stream out tonight. And finally, I just want to say again, happy Pride Month to everyone, and make sure you are all supporting each other out there, and let's build this community the way we want the community to be built. So I will leave it there. Thank you very much. Thank you to all our speakers. Thank you for making everyone who made this event amazing, and we shall see you all next time. Thank you.